All right. So let's just do a quick little run over binomial because you might remember that from last day. Right. So I showed you how to handle binomial expansion, a plus b to the power n, and to expand that, you'll get a to the n plus.
No, also bring it close. Bring it closer.
Can I get my belly down before I do some? Now, when I bring somebody up and I'll bring them to do a question. Nikolai. Okay. All right. So that was the binomial expansion, right? You plug in A, you plug in B, and you use NCR. Right, Emily? Right? And we did a few of these when n is a whole number. Right? But if n is negative, if n is negative or a fraction, we have a slight problem. Right? If it's negative or it's a fraction, we have a slight problem, right? If you go to calculator, try it from what is minus 5C4 and what is a half C3. Check the calculator and some more what you get. Error.
Yeah.
Right? Error here, error here. That's okay? But these values exist. Although you're getting an error in a calculator, these values exist. So we have to learn how to get these values, right? So I want to show you now how the formula will change a little bit. Just a little. I take it on your formula sheet. Where I have the formula. You got to crash course form? Yeah. Okay, so it's going to start advertise now, right? Wait, but I'll check the numbers. Right? And I want to do some revision classes Saturday and Sunday, right? Ideally Sunday for you. Ideally. If you can't come, well, come Saturday. Saturday and Sunday. An exam Saturday next week? Or this week? The whole day I hear Saturday. Whole day Saturday, whole day Sunday. Yeah. But ideally for all I want to come Sunday for it. Whole day I hear 8 to 6. So we can schedule 10 to something. Hold on, I just want to check you one. I just want to check your formula sheets. Yes. Right, I think they'll give you both versions. Yes, they do. Right? So in your formula sheet, they'll give it to you. All right. So, but I want to show you. Oh, let me just send it back in the group. So send it back in formula sheet in the group, right? The same formula sheet that you all use for applying. It's the same formula sheet that they use for here. Okay, 2 minutes, right? All right, so watch this here, right? So here's how it works. Everybody watch here. So instead of n factorial, NC1, sorry, you would just write n. Right? So if I ask for a half C1, that answer is just simply a half. That's okay? Now, here though, here's how you write it. If it's NC2, you write it like this. Right? You're writing 1 by 2 underneath, and on top you're writing n by a term just before it. Right? If you use this formula, it will give you a half C2. So a half C2 is this. I have 2 underneath, 1 by 2. So on top will be a half by a half minus 1. That's okay? So it shows you how to use the formula, right? And the right-hand side here is the same thing. Watch this here. NC3 will be 1 by 2 by 3. On top here will be n n minus one, n minus two by a to the n minus three, b3, and then it continue until you reach b to the power n. Okay, and just a small example. So all I want you to do for me, just try this one. 1 plus x to the power of a half. All I would like is the first three. In this small example, find the first three terms. I want to show you something in the formula sheet as well, right? Try number one left now. 1 plus x to the power of a half. Come on. But I want to show you something on the summary after, right? So 1 plus x to the power of a half, we're using this. So that'll be 1 to the power of a half plus n is a half, right? So that'll be a half by only after the first three terms, right? So that'll be a half by a, which is 1, to the x minus 1, n minus 1 by b. B is x. That's the first and the second term. And the third term will look like this. I'm rubbing this off because we are going to do the same thing. The third term will look like this. The third term will look like this, right? A half by a half minus 1 all over 1 by 2. Okay? So if it's 1 by 2, you should have two products here. If it's 1 by 2 by 3, you should have 3 products on top, right? And here would be 1 to the power of a half minus 2 by x squared. I only asked for the first 3 terms. So that's 1, 2, 3. So you can stop right there. Right? 1 to the power of a half is 1. A half by 1 to the power of 1 to the power anything is 1. X plus a half minus a half is minus a quarter all on 2. 1 to any power is 1 x squared. So simplify this out, you'll get 1 plus a half x minus 1/8 x squared plus dot dot dot. That's the answer. Anybody get up? Anybody reach all the way here? Are you confused? I just plug in was A, right? A was 1, B is x, and n is a half. Okay? Check it and make sure. Just want to show you something on the summary on the right to buffer. That okay with that? Right? All we're doing is using the same thing, right? The problem is that you can't find a half C1, so you have to use this here. Okay? That's all I have to remember. Right? So let me just give one more example. Let's go a little bit further. Let's say minus 3 all over minus 3C4. Let's go a little bit further, right? So the 4 indicating that you're multiplying 1 by 2 by 3 by 4, right? That's as far as you're multiplying, right? On top here with n by n minus 1 by n minus 2 by n minus 3. 1, 2, 3, 4 products, 1, 2, 3, 4 products. Right? Here, any comment last? Do you wanna? All right. So that's the way you work it out, right? So if you have 4 underneath, you should have 4, 1 by 2 by 3 by 4, and on top you start at n minus 1, n minus 2, n minus 3. That's okay? Right? That is the way you handle that's the way you handle NCR when you have a negative or a fraction, right? Something less than one. Okay, nice. Let's do one practice. There was a hard one I had someone. One time, we do our time. No, we have time. You gotta get something hard one time. Right. Here's the challenge here. I would like you to prove that online, some never seen it, right? Square root of 1 minus x over 1 plus x is approximately equal to oh yeah, try that in. The well, from the sheet already fixed, right? I was kind of but that other things as well, like our was up.
Nobody can get stopped, right?
So that it have like FIFA tournaments, what kind of little things that I was 7 or 8 different things.
But that's not gone.
5th of April,
That's not gone.
but I got a trophy.
Hey, so still.
Oh yeah, so here we have to do, right? We have to prove that when we simplify this, we're gonna get this. Any ideas how to start this? No, we do that here. How are we doing this? Any ideas? Right, I'll give you a little help, right? What does square root mean again, Shivish? 3 power of what? A half, right? So 1 minus x, 1 plus x to the power of a half, right? How I can simplify this out? I want to simplify this together. It has to do with something I showed you just now. What I mean, what is the same thing? So if I break this up, if I and this simply means both of them to the power of a half. But instead of dividing, I want to make it a little easier. Right, carry the bottom on top. No, wouldn't cancel off. Now we can expand this. Now we can expand this, right? And we can expand 1 minus x to the power of a half. We can expand that, right? And we could expand 1 plus x to the minus a half. And then multiply them. We do not want terms higher than x cube, right? So expand this out, expand this out. Let's see what you get. How far are you going? First what? 4 terms, no, 4 terms against cube. So like first 3 terms, right? Because you only want up until square. So find the first 3 terms here, first 3 terms here. Oh yeah. You know, come on, yeah, and start the talk. Oh yeah. Expand it fast. Expand this and multiply them quickly. Let's see if we get up. Can't hear that. You see that? Oh, yeah, no, no. Like that would be a good one. Yeah, that's what I'm saying.
Sorry, my life up to what's it?
Oh yeah.
It's not a problem from the box. So just plug it in place.
Yeah, plug it in.
It has worked though. Is your advantage on that?
Hurry up, expand it fast. But you now come to class, boy, you wait finish us already. Yeah. So that'll be 1 plus a half by plus, can you help me out here? The second one is what? A half by a half minus 1. 1 times 2 by 1 to the half minus 2. Sorry, all you please remember is minus x, minus x squared. No need to go further than that, right? Do the same thing here. No need to go further than that. Do the same thing underneath and multiply them. We will now reach just take a picture of what you get it. All done? What is one simplified to be here? 1 minus a half x is a minus. I'll still say a minus. So that's a half and a half by blah, 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 1/8.
And one mic, and one.
Anybody get that? 1 minus a half x minus 1/8 x squared.
Yeah.
Put one on top.
Yeah.
Right, do the same thing underneath. What's that, Davis?
And it is one multiply by 2 times of plus.
Where was it?
Plus half by half minus one.
Wait, tell me which line.
Yeah.
Line up.
Second, the last two.
Here,
Yeah, and one by.
it's a half by a half minus one. 1 by 2 multiplication. Here, same principle again. 1 plus, this is negative a half this time. So it's minus a half by 1 because it don't matter, right? 1 to any power is 1 by x. Plus, I'm doing the same thing again, 1 by 2. And the numerator is equal to minus a half minus 1 by x to the power squared. Right? This will simplify to 1 minus a half x. This is minus and a minus, so this is minus 3 and 2 minus a half. So that'll be positive 3 and 4 all over 2. So that'll be positive 3 over 8 x squared. Come on.
You know what I had?
Minus and a minus a plus.
Right.
So 3 over 4 divided by 2 is 3 over 8. That's okay? 3 over 8, right? X squared. And what's the next step? So I took this and I made it look like this. And they want me to simplify, make it look like that, right? So all I'm going to do now is to multiply these two out. So I'm going to multiply 1 minus a half x minus 1/8 x squared. I'm going to multiply by this. 1 minus a half x plus 3/8 x squared. I have a question, right? Look at what I want to get. Look at what I want to get. Do I have to multiply every single term in here? So one of the terms that'll give me what?
1 minus x plus 1.
Right, one of the terms that give you up to x squared, right?
Yeah.
That's okay? So when I multiply this here, I will get 1 by 1 is 1, 1 by minus a half, 1 by the x squared. Minus a half x by 1, minus a half x by minus a half is plus a quarter x squared. Stop there, I don't need any more, right? And then I'm multiplying 1/8 x squared by 1. And that's it. Don't need any other terms. Any other constants? No. Minus a half x is a whole x. 3/8 plus a quarter minus a 8 is a half. And that's it. All right. So the expansion should be easy. The hard part is this. How are you going from here to here to here? You're seeing that? So I took this fraction and I made it look like this, and then I brought it up and I wrote it further. That's what you have to recognize, okay? So therefore, this is equal to this. So that one more card though. Any questions online? Right, once you all sign up for the crash courses, I'm gonna send a little image so they can just have a share it around from around. All right?
Yeah,
Put on the name on the order. I think I have a space up on the order, just put it in there. Oh, well, send it. We get like that, right? Right, but if you show on the confirm sheet, you will do it. Right?
So you know, I didn't get to do it. I have to Google it and send me the explanation.
Sure.
Yeah.
So someone do it in come on, coach. But not. You see? Now I know it. Right, I caption and I highlight too.
After this, where's the like half who's out?
What's that?
Who's up? Let's get a little poor side.
No, what happened? Although what's let's call this guy way. But something I think I could do it as well. They don't show any motion. And then that pause. And do it smile.
That's not.
But I'm forgetting you. I just like that. I like that no expression on them. Alright, anyway, I think catch minutes.
Leave.
Or the catch minutes more so. One last part.
That part is not.
Yeah. Tens. Huh? This was worth 7 marks. This was long. This was a little tricky. Right? By taking hey, hold on, up here now. By taking x is equal to 1 on 17, show that the square root of 2 how are we doing this? Let's pick on Wyatt. Wyatt, here what they say. By writing x is 1 on 17, the way to show that root 2 is this. It's a hence. So you had to use what you gonna do? What you gonna do? Right? So you're gonna substitute x in here. Do some kind of thing and turn it into root 2. And substitute x in here as well, right? Some kind of thing you have to do. Try it. Take a minute and try it. Plug in x is 1 on 17 in here and see how that simplifies the root 2 tree. Well, yeah, those who need the help with some of these small all the other topics, they use the times I have there, right? Especially you. Same mother, some of them, but they so now something that they want from a thing on the group. So he can come every single, right? No, the best stuff, like find smart, do that. Right, that's
What price for the
everything is safe. No, all night, that's what 215. I used to say they come last year, so this is the price from now. I know, just tell them when you have the receipt.
No.
Tell them when you pay and they'll find the receipt. I want somebody to.
I didn't talk about it. Less than a year.
Or just tell them. Yeah, write it out. Go and tell them now. Nobody can't call them now. Yeah, just go and tell them.
They phone me after I going, but I know I going, but I forgot that. I know I going, why you telling me that?
Alright. So if you plug in 1 on 17, she in the office there, give her one time. You have a next month. You have no lessons next month.
Yeah, that's the next one.
Next month is a crash course.
Get in the office.
So they last,
Yeah, we will be able to.
last, they can say.
Yeah, but she gonna leave. She gonna leave. Go on time.
It could be.
Huh? No, well, probably me to I thought made that mistake. Yeah. Right. So watch this here. When you plug in this here, what you getting? 1 minus 1 on 17 is what? 16 on 17, and what about here? What you get? What you get underneath here? 18 on 17. When you flip them up, what you'll end up with? 16 over 18, right? And then if you simplify that a little bit further, what you will get? 2 is that what? And you will get 4 over 3 root 2. What I get that? Number 16 is, if I divide both of them by 2, that'll be 8 over 9. Right? If I simplify 8, 8 will be 2 by 4, right? So I get 2 over 3 root 2. Right? 2, okay. They can simplify further. So I'll end up with 2/3 root 2. Okay? So I'll use that because you get any calculator. Okay. Nice. So what it's saying now is that if I put 1 on 17 here, and I put 1 on 17 here, this is 2/3 root 2. Okay? But I am interested in what? Root 2, right? So I'm going to have to remove this afterwards. So I'm going to focus on the right-hand side now, here. And I'm going to do the same thing. 1 minus 1 on 17 plus a half by 1 on 17 squared. How much is this? 545 over 578. So everybody watch here, please. Watch what happening now. Here's the part that I have to just do a little simplification, right? If I let the left-hand side equal to the right-hand side, I will get 2/3 root 2 approximately being equal to 545 over 578. That's okay? These two things happen by just plugging in 1 on 17 here, 1 on 17 here. But the question asks me to show this. So I have to move across 3 on 2. 2 on 3 here, and it becomes root 2 is 545 over 578 by 3 on 2. Because I'm flipping this on this side. And that should simplify to this. 1635 over 1157. That's okay? It's a popular question. Then I'll give you our next one. Tell me.
It's here 1156 is out.
1156
is out.
is approximate. It's approximate. Where we get? No. I just break it up. I'll show you something. That's 2 by 4. Simplify it. I will show you how they end up for this. Come here, follow on. Right, so here what they said. They said by taking x is 1 on 17, show this equal to this. So what you have to do is plug in 1 on 17 here and 1 on 17 here. Both sides. You plug in 1 on 17 on the left side, you will get here. If you plug in 1 on 17 on the right side, you will get here. So it means that this equal to this. This equal to this. And I move across 3 on 2 to get it. Yeah, well, probably wrong though. No, it's approximate. It's approximate. It's approximate. Everybody okay with that? Let's just try one more now.
Something like that.
Yep. This is 2013. Let me go have it on there. Oh yeah. Online, any questions? Oh wait. Online send something here. No sir, no sir. Oh. One, like a pretty hard one, right? Right, try this here. This looking like the 22. Oh no, it's not. Ignore part A. I'm not interested in part A. Part A easy, right? Let's focus on the hard one. Part B. I think that's 2013. Part B in 2013. Ignore part A. That's just the basic expansion. You want to do it right ahead. That's part B.
No. I still in 6 months.
Hey, you Sean, this is why I was talking about science.
That's what.
I don't know when I was.
Oh, yeah. That's something.
Oh, yes, everything.
Yeah, that's quick.
Finish. Alright.
Right, show it and then do part 2. Take your time with it. They tell you what to use. Okay, try it quick.
So they come to any time, so that's not the assembly.
Yeah, but Sunday I usually call it.
Okay.
And Saturday is pretty cold, like, but it's still come out the pain and then come.
Well, I'm sure that's true.
Anything all the good.
So like, economics and down, you understand it.
No, but that's us.
You can see it.
Oh, actually, so.
No, what, you can bring it, guy, you can bring it, same that bus guy, and bring it, either next day. We can't travel soon.
Last time I traveled to my farm,
Oh, that's what, yeah, that's now,
I probably, it's probably relaxing.
so I still go, I have a lotion. I can't say anything. You can't see for.
Yeah, it's.
We got some. We use it.
You say, it doesn't become can't do that. But she, you need, yeah.
Right, so yeah.
Yeah.
But you can't simplify it much further. Right? After you do this, you just have 2 more things to do in expansion. McLaurin's and Taylor. Right? And then next week you'll finish up the loop then. Saturday I'll start the Monday, I can't do any other. Question on the board, sir. Green, I mean. Ignore part A, just doing part B. For example, Alright, can I start it? So it's not working out. Right, they want the answer to 4 decimal places. But look at you, part 1 though. Sean, part 1 work out? Yeah, B part 1, sorry. Oh, what you get wrong? Alright. Okay, let me check it and see.
Ready answer?
Okay, which one?
Part.
Part 1's a proof now.
We didn't even get that.
Well, I'm just. I give you a minute and I'll start. I can't do it now. Right, Olia? Remember, we have the. Alright, so what is here, right? So to expand this out, oh, what is that thing? Power of what? Oh, of the power of 2. Okay, nice. So that's 1 plus a quarter by 1 by x. Right? Then you have 1 by 2 here, you have a quarter here, a quarter minus 1. By 1, remember 1 to any power is 1 by x to the power of 2. So the top part will simplify to 1 plus a quarter x minus 3/4 by a quarter is minus 3 on 16. So that would be minus 3 on 32. Anybody get up? Yeah, minus 3 on 32.
So then you'll get 1 plus a quarter minus a quarter x plus 3 until 2x squared and cancel this thing.
For your next one.
Yeah.
And the question is hard, right?
Yeah.
So it's not working out.
You can do this. You can.
No.
Anyway, now you see, right? So this will be 1 plus a quarter by 1 by minus x to the power 1. Plus underneath here will be 1 by 2. On top will be a quarter by a quarter minus 1 by minus x squared. So this will be 1 minus a quarter x. This will be same thing as before, right? Minus 332 x squared. How they cancel off?
The sub copy minus 2.
Sorry?
This is here.
Here,
On top is minus.
how do you top it minus with? Tell me.
Yeah, hold it.
Here's minus,
Yeah.
because here's minus. 2 is minus x squared is positive x.
That's a minus.
Where? Minus and minus where?
The bottom. We have been minus.
Here is minus, right? But it's positive, a minus by a positive is minus. Here is positive, here is minus. Oh, what positive? Minus x squared is x squared. Here is minus.
What?
This whole thing here is minus. Okay? So now, so 1 plus x to the power of a quarter plus 1 minus x in quarter. When you add these two, you add in this here. So that's 1 plus a quarter x minus 332 x squared plus, it's a plus, so I don't have to put in bracket, right? 1 minus a quarter x minus 32 x squared. The x term will cancel. 1 and 1 is 2, minus and a minus, so that's minus 6 on 32 x squared. That's the answer. Oh, reduce it. So that'll be what? 3 over 6. Okay, so this is equal to this. You all got through with that? That's the one I'm interested in. Everybody try it, please. Yeah, it'll be 74%. This is the fourth root of 17. Try that, please. They want you to, I can't remember, you didn't write it down. They want you to, no, compute this to 4 decimal places. Work out this to 4 decimal places by using this. So you have to substitute this, both sides, and simplify. Same thing as before. Are you done? Huh? Right, plug in 1 and 16 on both sides and see if we can get the answers for this. You want this answer to 4 decimal places. You want the answer for this to 4 decimal places. Without, but by plugging in 1 and 16, right? On both sides. No, they gave it up, so you had to find a way to simplify it, to make it look like that. Just like the last one, plug in the value on the left side, simplify it until it reaches that. Plug in the value on the right side and create them. Just like the last one that we did. Take 1 on 16, plug it in here. They told you to work with that. So work with plug in 1 on 16, plug in 1 on 16. Simplify it out. Plug in 1 on 16 here as well. Simplify it. And then when you equate them, make the left-hand side look like that. And then the right-hand side should be an answer. Oh yeah, plug it in. Let's see what you get. You're done? Right tree. Where you get? Left-hand side. The left-hand side is 1 plus 1 on 16 to the power of a quarter plus 1 minus 1 on 16 to the power of 1/4. When you simplify this will be 17 on 16 to the power of quarter. This will be 15 on 16 to the power of quarter. That's okay? What you're interested in making it look like? 17 to the quarter and 15 to the quarter, right? So I've seen the 17 here, I've seen the 15 here. So we could probably say 17 to the quarter over 16 to the quarter. 15 to the quarter over 16 to the quarter. If I simplify that, it will look exactly like what I want to get. 16 to the quarter is in this 2 ends.
Yeah.
Right? So it will be everything over 2. That's okay? And then work on the right-hand side now. Work on the right-hand side. Plug in x squared is 1 on 16. How much you get here? 81 over 1496. So 81, 89 over 4096. Right? But that's not the answer. What you want the left-hand side to be? Right. Root 17 plus root 15. So you multiply by 2 and you will get root 17. Sorry, 4th root of 17 plus the 4th root of 15 is 2 by this. Right, the question did not ask for a fraction, they asked for 4 decimal places. Yeah, 4 decimal places. How much is that? Okay, 4 decimal places. Right, so I'll work with the left hand side and the right hand side. And then simplify it to give me what I want. Right, same thing I did in both of them, right? Right, some of these here we could expand it using our next technique called Taylor series. Right, so I just want to show you that, how to use Taylor series and how to use Maclaurin. Very easy, but the problem with it, you have plenty of differentiation to do. This one, yeah. This technique is how I use this one. This 2013. The password. What's wrong with the TD? It has plugging in a value.
Yeah, but
And they tell you-
where to forget it,
But
right?
imagine they do tell you what to plug in. That's where the problem will come.
So
Right?
give me an extra minus.
I'll give you one. Right, but all you have to do is you just plug it in on the left side,
Right, I
And
get
you are-
through that, I get through now.
on the right side, so you should reach here,
I don't know why you're still.
because you just take a quarter on top of a quarter on it, and it should reach here. When you reach here now, this looks like, this looks like that.
Yeah, we took it. Yeah, that is.
Alright, good job, Samira. Alright, so we have one more thing to do in expansions, is Taylor and Maclaurin. Right? Not difficult at all, and if you check the formula sheet, I think they just give you Maclaurin. Right? Whoever have the new version, they'll give it Taylor in there as well. If you all get the new formula sheet, it has Taylor series in it. Huh? Nice, whichever ones they have. I'll give you both versions. If you want to find it, they have not yours. Taylor or Maclaurin? Give it both. Alright, so here's how we're doing, right? If I ask this use Taylor expansion, you can use it for all the questions that we're doing. all you have to do, I'll give you a value that we're going to define f of x around. Let's say a is 4. You plug in the values here. You differentiate, plug in the value for a. You double differentiate, plug in the value for a. Triple differentiate, plug in the value for a. That's all. All you do is take in f of x, plug in a. Right? Find f of x, plug in a, write the answer here. Find f prime x, plug in a, put the answer here. F double prime, find it, plug in a, and so on and so on. Okay? They will tell you that they want 4 terms, or they want 3 non-zero terms, and so on. Really easy. If they say Maclaurens, all that will change is that a is now 0. That's it. Really easy. Okay? The hardest thing is you have to remember how to differentiate. Okay? Copy it down. Let's do an example. Right, in your formula sheet, they will give you the same formula, but the old ones doesn't have Taylor, it has Maclaurens. So instead of an A, you'll see 0. Well, you wouldn't see anything, right? You just see X or X squared and so on. Okay. Ready? Let's try one now. Am I done? Right, so let's try an example. Find the Taylor expansion. Find the Taylor expansion about x is equal to 2 for f of x is equal to ln 5 plus x. So, right? If we're not going far, let's go up to x squared. Okay? Right? So if you don't write the formula down, all you're doing is this. You write down what's f of x, which is ln 5 plus x, and the first part of the formula is f of a. So a is 2. So I want you to find f of 2. Your answer is ln 7. All okay with that? 5 plus 2, 7. Yeah? See? Next part, you have to find f prime x. What's the differential of this? Yet, Timothy says you now reach back there. What's the differential of this? 1 over 5 plus x, right? To differentiate ln 5 plus x, denominator, numerator is the differential of that. Then they want f prime 2. So that will be 1 over 5 plus 2 is 7. That's okay? Double prime. How we differentiating this division? How we differentiating 1 over 5 plus x? And what is that? Right, so instead of writing, you can use chain rule or shortcut, right? you can use shortcut, right? Bring down the power. Write back this minus 1 to the power. Right? Bring down the power, differentiate inside the bracket, which is 1 minus 1 to the power. And you're done. F double prime 2, that will be minus 1 over 2 plus 7. 2 plus 5 is 7 squared is 49. Are you okay with that? Benaya? Right? So, and the only one up till x squared, right? X squared is right here.
Yes.
No, sir. They said about x is 2. Right? So they will tell you what to use A as, right? So this is our A value here. And you're done. So you can tell them now that f of x, which is ln 5 plus x, could be written as, actually, let me write that. Ln 5 plus x can be written as f of A. What's f of A again? Ln x, ln 7 plus x minus 2. Oh, yeah, what is here, right? Whenever you're using Taylor, you should always have x minus A. Right? Most people remember Maclaurin and they leave out this. Right? In Maclaurin, doing the same thing, just everything will be 0. Okay? So x minus 2 by f prime A. F prime A is 1/7. Right? So that's here and here. Now here now. Plus x minus A squared. So that's x minus 2 squared all over 2 factorial, which is 2. Multiply by f double prime A, which is minus 1 on 49. That's it. You can stop right there. Make it look a little bit nicer. Ln 7 plus 1/7 by x minus 2. This will be minus, right? 2 by 49 is 98. X minus 2 squared plus dot. Okay? That is your that is Taylor's expansion. Okay? Suppose I said Maclaurin Shirish. What to do? Huh? Take out the A and put 0. So instead of finding f of 2, you find f of 0. Okay? This is easy math. Sometimes this is 14 marks something, huh? Because the differentiation be harder. Let me just show you one quickly. You have time to finish one? That's not. Welcome to. I don't know.
Okay. Okay. You don't yeah, I have to here, I got my shoes. No, I do a class. She does class, the day gets to the conference. Except I figure it. 20 minutes to read what I can vision.
Right? Watch this here. That's a Maclaurin. Just tell me what to do now. You can start it now. That's a good idea, either.
So we'll finish, we'll do it Sunday. We'll do Sunday.
Right? So on Sunday, yeah, we can practice all
Okay,
of
Sunday.
this.
Okay, we know.
Tell me what to do now. We're using, I want to make sure we using the right thing. We're using Maclaurin, so x is what? 0. Right? But how we differentiating that? Huh? Bring these, somebody say that. Bring these. Don't ever do that, please. You cannot do that with sign. How you bring the x on 2 in front? Third up rule. Right? So you cannot do that third up rule, right? Well, that's why it is marks. Okay? Sine and cos and tan, you cannot move the half out of there, right? Those functions not like that. Oh yeah, start it fast, because I'm not going to do it over. Start it fast. Start it quick.
Okay, there.
You can take a picture.
Yeah, and just also just think like.
Alright, so try to homework, right? On Saturday and Sunday, if you all come, well, preferably Sunday, we will do some more practice on this and
We could come any days from now until Monday.
any day is like the I'll have there. A send the list,
Where does it come?
ideally, yeah, but I will do a little Google form later.
Also, we have to do the
Your name, whoever, time they want to come. I don't want to come here Sunday, look like nobody here.
What's coming in?